Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video we are going to explore MSK Connect. But before going ahead with this particular topic, you should have a clear idea on the fundamental concepts of Kafka Connect and how to work with Snowflake Sink Connector, which I already discussed in our previous videos. Okay, so if you know those concepts, well and good. But if you are not aware of those concepts, I will request you to go through those videos first. The links I'll be sharing in the prerequisite section in the description box. Okay, those videos will surely help you to understand today's concept in a much better way. So just a quick recap. What is Kafka Connect? Kafka Connect is an open source component of Apache Kafka that provides a framework for connecting with external systems such as database, key value store, search indexes, and file system. Right? That is, whenever you need to move the data from external system like databases, key value store, search indexes, file system, etc. to Kafka, or whenever you need to move the data from Kafka topic to some external system, then if we want to use some reusable code just by changing little bit configuration in the config file, then we can go ahead with Kafka Connect. But what is the common problem while working with Kafka Connect? That is, manually running Kafka Connect cluster requires you to plan and provision the required infrastructure, deal with the cluster operations, and scale it in response to load changes, right? So all these things we need to take care of when we manually run Kafka Connect. Now there comes AWS MSK Connect, which helps us to avoid the infrastructure burden. Okay, so MSK Connect allows you to configure and deploy a connector using Kafka Connect with just a few clicks. It provisions the required resources and sets up the cluster, okay, where actually our Kafka Connect is running. It continuously monitors the health and delivery state of connectors, patches and manages the underlying hardware, and auto-scale connectors to match changes in throughput, right? So all this infrastructure burden is now MSK Connect is taking care of while working with Kafka Connect, okay? And as a result, you can focus on your resources on building applications rather than managing infrastructure. Okay, so we can think MSK Connect as managed version of Kafka Connect. Okay, right? And now we got little bit essence that what this particular MSK Connect actually does. Now let's see how we can use this particular one in building real-time service. Okay, so already in our previous video, we configured the Snowflake Sink Connector in our local system. Now we are going to configure the same Snowflake Sink Connector, which basically read the data from a particular Kafka topic and write in a Snowflake table. But that Kafka Connect we are now going to configure in MSK Connect. Okay, and the architecture can be shown like this way. Basically, we will be having a VPC. Within VPC, we are having two AZ. One is AZ1, one is AZ2. Okay, for higher availability purpose, we will be having two MSK brokers which will be running in two different AZ, so that if there is some issue with one subnet or one AZ, other AZ can serve the required services, right? So here for security purpose, the brokers are configured within private subnet, as you can see here. And what we will do to publish the data in MSK topic, which are running basically in private subnet, we will first enter in a public subnet EC2. From there, we will do SSH in a private subnet EC2, which is basically having all traffic allowed to that MSK cluster. And from this private subnet EC2, we will try to publish some data in our MSK topic. From there, we will see that if we configure our MSK Connect properly, from the topics, the data will be flowing to our Snowflake table in real time. Okay. So without any further delay, let's directly jump into the implementation section, right? So first step, what we will do, because MSK takes some time to launch it. So as a first step, what we will do, we will launch the MSK cluster, okay? Obviously, you can understand from this particular diagram that in this particular EC2, if we try to set up the connection with our MSK, then in that case, we need Kafka downloaded in this particular EC2, right? Even Java should be there. So we will enter in this EC2 instance from this public subnet EC2 and install those things. So for downloading purpose, in this EC2 internet access is needed, although it is in private subnet, right? So what we will do, we will configure NAT gateway in public subnet, and in the route table for our private subnet, we will configure the NAT gateway. Same network configuration what we did in our previous video also. And then we will launch the MSK cluster in private subnet, okay? So here I will log in into my AWS Management Console. Now first here I will go to VPC and I will create a NAT gateway quickly. So here I'll go to NAT gateway, create NAT gateway, demo YT connector, okay, subnet. So if you have watched our previous video where we configured the complete VPC, public subnets and private subnets, then you should be knowing that we created 4 subnets basically. One is public subnet B lambda, one is public subnet A lambda, one is private subnet A lambda, one is private subnet B lambda. Okay. Now NAT gateway has to be sitting in public subnet. So what I will do, I will choose public subnet A lambda as subnet, and here I will allocate one elastic IP. It is done, and then here we will create the NAT gateway. Okay. Once the NAT gateway is created, what we will do, we will update the route tables for our private subnet so that it can access internet via NAT gateway, right? So let's wait for a couple of seconds. So here you see our NAT gateway is now available. Now I'll go to route tables, and here public route table, this is basically for our public subnets, right? Here if you see in the route here, it is having internet access using internet gateway, right? Now we need to update in private route table. Here this is the one. I will go to that. I will edit the routes, and here earlier I created this NAT gateway which I deleted after doing the experiment in my previous video. So here the status is now black hole. So I will remove that, and then here I will make sure that internet access is available via NAT gateway. Okay. So this is the one. I'll save the changes. Right. Now that is done. Now what we will do? We will quickly create one MSK cluster because it is going to take some time. So let's deploy it, and then we will follow the further steps. Okay. So here you can see create cluster, custom create, cluster name demo YT28 cluster. Some name I have given, provisioned cluster, Apache Kafka version, let it be as it is. Now here broker type. So here this is just a POC, so I will choose Kafka T3 small, number of zones 2, broker per zone 1, same configuration what we used earlier. Amazon EBS storage per broker should be 1 GB, just a POC we are doing, that's why. I will click on next. Here I will choose our virtual private cloud what we configured. Now here one subnet we will choose in US East 1A, that is basically our private subnet A lambda. Another one I will choose in another AZ, and that should be private subnet B lambda. Okay, public access off. I will keep the security group as default one only. Click on next. Here as of now let's start with unauthorized access, and plain text encryption also allowed. Within cluster TLS encryption is fine, right? Click on next and keep these properties as it is. Click on next. Then here just review once whatever we have configured. So here unauthorized access is enabled, plain text enabled, within cluster TLS enabled. It is looking good. Now what we will do, we will create the cluster. Okay, right? So here the cluster is going to take some time. So the first step is done. Basically we have launched our MSK cluster. Now let's go to the second step. So what we are doing here basically, if you recall our previous video where we have configured our Snowflake Sink Connector for Kafka, there we need the public key file and private key file for setting up the authentication, right? So that private file and public file will be generating. So those files I will be generating and saving in this particular empty folder. So to generate those files, I will first launch command prompt pointing to this particular directory, and I will be using OpenSSL. So here I will basically launch WSL or Windows Subsystem for Linux within this particular empty directory. If you just see, if I execute pwd, here see this same directory it is pointing to. Now to generate the private file, here I will execute this command which we used earlier also. It is done. Now here to generate the public key file, here I will execute this code. Okay, so both is done, right? Here see both got generated. Now the point to be noted is here rsa key.pem file, this file, if you observe, you will see that there are a lot of spaces and new line characters etc. available. But when we will configure this in the configuration file for our Snowflake Sink Connector, it should not be having any new line character or space etc. right? So to remove those, we will be executing these two codes. So here Snowflake private key file, we will first read and we will replace all these spaces and new line character, and then here we will write them back in RSA key p8.out file. Okay, right? So let me just execute that quickly. Here, first step is done, and then here let us run that. Okay, so here it is done. Now let me show you what is the difference. So if you see this particular file, the private key file is looking like this. Obviously it is having new line character, etc. But now let me show you this particular out file. If you see, this is coming within a single line. Okay, all the new line characters got replaced, right? So this one we'll be using in our Kafka Connect configuration. That's all I'm trying to say. Cool. Okay, right, up to this step it is very simple. All these steps I'll be providing in the description box or in the comment section also, so that you can basically parallelly do experiment on these steps. Now what we will do, we will basically open our public key file using cat command. We can open, or directly also we can open, not a problem. So if I open, so this is what is the content within our public key file. Okay, now we need to configure that in Snowflake. So let's go to Snowflake and execute some codes that looks like this. So I will copy these codes and I will open my Snowflake account. So here I will open a new worksheet. I'll paste all these codes. So first step, what we are doing, we are dropping a database RAML if it existing. Then here we are creating a database. Now here, for using the Snowflake connector for Kafka, we are going to use one user ID called Satudru, and in that only we will configure our public key. Obviously, for this kind of Kafka Connect configuration in production system, you can have a separate user ID and password, separate profile. But because this is a simple POC, I am configuring in my account admin user ID only that particular public key we are configuring, and here it is done. Now here, if I just use describe user Satudru, we will see that particular public key configuration is there. Let me just show you. So here see RSA public key. This public key got configured. Okay. Now here we will use this particular database. As of now, if I do show tables, here we will see no table is there, because just now we dropped this particular database and created it freshly. Okay, but at least the public key configuration is done. Now what we need to do, we need to start working on the launch of this public EC2 and private EC2 and setting up the integration and all. Till then, let MSK cluster get spinned up in the backend parallelly. So what we will do, we will open AWS Management Console in a new tab, and we will launch two EC2 instances, one in public subnet, one in private subnet. Okay, cool. So here I'll go to EC2, and then here instance I will go, and here launch instance. So here I can give the EC2 name as public EC2 demo. Okay, Linux machine only I am keeping, right? T2 micro is fine. Create a new key pair. So I will just create a ppk file connector demo. This is the one. Suppose I will create the key pair. So it is done. Now here I want to configure this particular public EC2 in public subnet for the same VPC, in which VPC we have launched MSK cluster, right? So here I will choose that. Here this is the VPC where we have launched our MSK cluster, and here I will choose public subnet A Lambda. Okay, public IP I will enable this one, because we will enter in this public subnet EC2 using putty. Okay, so here we will enable that, and then here keeping other properties as default, I will launch the instance. Okay, right? I hope up to this it is very simple. And then here again we will go back to EC2 instances, and here I will launch instance. Okay, so here I can give the name as private EC2 demo. Okay, cool. Amazon Linux machine only I am keeping, and then here key pair I will choose just now what key pair we have created, that is basically this one. Okay, here I will edit the network configurations, and I will make sure that it is also running in same VPC where our MSK is running, that is basically this one, and here it should be running in a private subnet, right? So for example, I can choose private subnet A Lambda. Okay, auto assign public IP not required for this private EC2. I will scroll below, and here I will launch the instance, right? So here both the instances are launched. Now what we need to do, if you see, this private EC2 is having a separate security group. This MSK cluster will be having their own security group. We need to make sure that they can able to talk between each other without any disturbance. Okay, so we need to configure their security group to allow all traffic when they are communicating between each other, right? So here I will do that. I will go to our private EC2 and here I will go to security group, and then here I will click on this, and here I will edit the inbound rule. I will make sure that all traffic from our MSK cluster is allowed in this private EC2. Okay, so I will go to my MSK cluster properties section, and this is basically security group for our MSK. I will copy that and here I will paste that. Okay, and I will save the changes. This way, from MSK cluster, all traffics are allowed to our private EC2, right? Same thing we have to do in reverse way. So I will go to our MSK cluster security group, right? And here I will edit the inbound rule, and I will make sure that all traffic are allowed from this EC2 security group, which is basically this one. Okay, I'll copy that, I'll paste that here. That is done. Save the changes, right? So here network configuration is done. I can close this window. I can go back to EC2 dashboard. Here let's go to instance running. Here our both instances are running, right? So up to this, I hope it is very simple. Now as per the next step, what we will do, first we will enter in this public EC2. From there we will try to do SSH in private EC2. But to do SSH in private EC2, we need the PEM file, right? But as of now we are having PPK file. So from PPK file we will create the PEM file. Okay, so for that we need puttigen. I will open puttigen and I will load the file. Just now what I downloaded, this one, open that. Okay, here conversion, export OpenSSH, yes, and then here I will put that in the same directory where we created our public key and private key for Snowflake connection, right? Here demo connector, here maybe let me give, so here connector demo dot pem. Okay, so this should be our PEM file what we can use. Okay, that is done. I can close this one. Now here I can open WinSCP to move that PEM file from our local system to this public EC2. Okay, so I will click on this public EC2. This is the public IP. I will copy that one, and here I will do SSH. So username for this Linux machine, it is EC2 user. I will go to advanced section. I will choose the PPK file to do WinSCP in that cluster. So here it is done. I will make this bigger, and now here I will go to that particular directory where all the PEM files are available, and this is the one what we needed. We will just drag and drop to our public EC2. Okay, that is done. Now let's enter in this public EC2 using putty. So login as obviously default login ID as EC2 user. So here we have entered in public EC2. To avoid timeout issue, we will just change the connection setting to maybe 10 seconds. Okay, cool. Now here if I just go back to instances, and here if I check this one and click on connect for my private EC2, I will see these two ports what our AWS is suggesting. So first we need to give this particular 400 access to this PEM file. So if I do ls, here you will see that this file is there. Okay, so I will just hit enter. It is done, and now here we can use this port to do SSH. Okay, in our private EC2. So here I will click on yes, and it is done. Now we are in private EC2. If I do ping google.com, you will see that it is working. Why? Because NAT gateway is attached with this route table of our private subnet. That's why it is working, right? I hope you are easily getting this, already done multiple times. Now we will first install Java in this private EC2 and download Kafka also, because we need Kafka topic.sh, Kafka producer.sh, Kafka consumer.sh, etc. code to do the experiment. Okay, so as per next step, we will first download Kafka. So here it is done. I will just execute this command. Now here we will unzip that. Okay, that is done. Now here we can go to this particular directory. Cool. If I do ls, here you will see all the codes are available. Okay. Now here we can use Kafka topic.sh script to create a topic. Suppose the topic name is demo testing 2. Here we need to provide the bootstrap servers. Okay. So where we will get the servers? That is basically we will get from our this MSK cluster. Once it is ready, we will get the bootstrap URL. So we will put that here, right? And then we will create a topic in our MSK cluster. Okay, cool. And parallelly, we need to start setting up the connector part, right? Because that's our today's main topic, that how to configure this MSK Connect. So for that, what we need, if you recall our previous video, we need a jar file. So let's download that jar file and make it ready. So to create the custom plugin, first we need to download the jar file. That jar file is basically having the actual logic, which is basically reading the data from a particular Kafka cluster and writing in Snowflake table, right? So that jar file I will download. Okay, just click on this. Here the jar file will be downloaded. Now here what we will do, this is basically called custom plugin. So this jar file I will upload in an S3 bucket, right? And then we will create a custom plugin. We will say our MSK that use this particular code as a base code to move the data from Kafka topic to Snowflake. Okay, so that is termed as custom plugin. So we will use this one. So here what I will do, I will go to S3. And here we will create a bucket, connector demo, maybe for example YT. Okay, create the bucket. So here bucket is created. I will go inside that. I'll upload. You can use any existing bucket also. Any folder is fine. I will choose that particular jar file. I'll click on upload. Okay. So here it is going to take some time. By that time, let's try to create our custom plugin. So here I will go back to our MSK window, and here if you see that MSK Connect option is there, which basically manages our Kafka Connect, right? So here if you see the option of custom plugin is there. I'll open that in a new tab, and then here we will create a custom plugin. Okay. So here if you see, an Apache Kafka Connect plugin is a set of jar file that containing the implementation of one or more connectors, transformations or converters. Okay. So here our Snowflake Sink Connector is actually configured in that jar file. So that jar file we have uploaded in S3, and that S3 URL we have to paste here as part of our custom plugin, right? So here it is uploaded. I will go back here. I will click on this and I will copy that S3 URL, and here I'll paste that. Okay. Custom plugin name, Snowflake Connector jar plugin. Some name I have given, and then here we will create the custom plugin. Okay. So here it is in creating state. So here see, it is done. Okay, cool. Now here we will switch to creating the connector. But before that we have to wait little bit until our cluster become in ready state. Okay. So still it is in creating state. We have to wait little bit. Let's wait for that much time, and then we will start creating the connector. Okay. So here if you see, our cluster is now in active state. I will click on that, and here if I go to view client informations, here we will get the broker URLs. Okay, so we will now configure our connector as well as we'll be creating our Kafka topic also. Okay, so here in the bootstrap servers we will paste that, and here we will complete our Kafka topic creation, that is basically demo testing 2. Okay, so here let me just create that one. Okay, so here the topic is created. Perfect. Now here we already created our custom plugin. Now here we need to create the connector, right? So here what I will do, I will go back to my connector console, and here I will click on create connector. Okay, so first I will choose the plugin what just now we created. I will click on next, and the connector name Snowflake Sink Connector Demo YT. This is the name I have given, right? which MSK cluster this connector will run. That is basically this particular MSK cluster what we launched just now, right? And here connector configuration. So we need to give the configuration also. So if you recall, already in our previous video, we configured these things like connector class. We need to mention that it should be Snowflake Sink Connector. Maximum task we are keeping 8. If you want, you can keep more to do more processing parallelly, etc. The topic name, from which topic it will be consuming the data and write in a Snowflake table. So that topic name we are providing as demo testing 2. What topic just now we created. If you see here, right? So here we have given the same name. From this topic, in which Snowflake table the data will be written, that table name here we are keeping. The table name is fake data real-time demo. Okay, right? So as of now, the table is not there in Snowflake, as we have seen that the Ramu database we created freshly, but we will see that automatically the connector will be creating the table for us, right? Now buffer count of records, buffer flush time, buffer size bytes. Based on these properties, the data will be flushed from topic to Snowflake table, right? So whatever condition will be satisfied first, based on that the data will be flushed. Now here Snowflake URL name. So here we need to provide the URL name for our Snowflake account. If you go through this particular link, you will see that what to write in the Snowflake URL name. Let me just show you. Here if I just scroll a little bit below, here you will see that for North Virginia region, here we need to give the unique identifier for our account. Along with that, we need to give .us east1. So this will make our complete URL. Okay. So here I will go to my Snowflake account. If you see here, the unique identifier is basically this one. So I will copy that and here I will paste that one. Along with that, I will give a dot because this is running in North Virginia region. So here I will follow the .us east1 also. Okay, right? And then here I will give another dot and here I need to give snowflakecomputing.com, right? snowflakecomputing.com. Even you can just test it out. So just copy this particular URL and paste in your Chrome browser just to check whether it is leading to that particular account only or not. So it is taking to that account, so not a problem. Okay, cool. So here that is done. Now username. So username I am giving Satodru because if you see in our this particular Snowflake here for the user Satodru we have configured public and private key. So I will use that. Now Snowflake private key. So private key will be configuring. We will be using that one basically in which we have removed all the new line characters and empty spaces etc. So here I will copy that one and here in Snowflake private key we will paste that, right? Now database name. In which database our table will be created? That is Ramu database just now what we created, right? What should be the schema? It is public schema. You can obviously create some other schema and use that, not a problem. Now here key converter, value converter, we are keeping both as JSON only because mostly we deal with JSON data in this kind of real-time scenario. And here name part is optional, it is not needed. I can delete that. And now here I can copy all these properties and here I can put in Snowflake connector. Okay. So here I will paste on this. Perfect. This is done. Now here I will be configuring the connector capacity as provisioned one. Number of workers as of now I am keeping 1. You can increase this obviously if it is required, right? Worker configuration I am configuring as default one only. IAM role. So here we need to create one IAM role for our this MSK Connect. So I will create that. Okay. So if you see that step I have written here that for IAM role creation, I will just give a dummy role, maybe suppose S3 full access I want to provide, and then here trust relationship will configure. Okay. Although in this case actually IAM role is not needed, but just for requirement purpose we'll be configuring that. So here maybe for S3 I will create the role. Maybe for example S3 full access I want to give. Then click on next. Role name demo connector YT Kafka. Okay, I will copy this one and then here I will create the role. Right? As simple as that. Once the role is created, I will go to that particular role and I need to update the trust relationship. And that trust relationship should be this particular one what we need to put as per AWS documentation. We cannot put some other value. Okay. We need to make sure in the account ID part we are putting the account ID whatever we are having here for our account. Okay. So here we will copy this particular one and we will update the trust relationship for this particular one. Okay, edit this one, paste this one and update the policy. Okay, that is done. Cool. Now we will use this particular IAM role in our connector. Okay, so I will copy that one. Right here I will go back to my connector page. I'll just refresh this one and here I will search that one what just now we created. Now I'll click on next. Access control encryption keeping as it is, fine. Now here whatever logs our connector will be generating, that we want to publish in CloudWatch. Okay, so in CloudWatch maybe we want to create a log group. So here I will visit the CloudWatch log console. I can close the IAM window, not required. Even this window also I can close, this window also I can close. Okay, and here create a log group. So for this particular connector's log capture, I will create a log group. So demo YT connector logs. Okay, this is the one I have given. Retention period never I want to expire. Obviously you can expire the logs after a certain amount of time, that is perfectly fine. Here I will create the log group and then here I will go back to my connector console and I will browse that particular log group just now what we created. Okay, I will choose that one. I'll click on next and then here it will be showing you the configurations whatever you have configured. Okay, just before finalizing, just review once, it should be fine. And then here we will create the connector. Okay, so obviously it is going to take some time to create the connector. Once the connector is in ready state, what we will do, we will publish some messages using console producer and we will see whether it is getting consumed in Snowflake in real time or not. Okay, we will not start any Kafka connector locally or in our EC2 instance, because that time if we launch manually, then all this infrastructure we need to handle. But in this case, we are using the MSK Connect, which is handling all that infrastructure part. Just we have configured that properly. Okay, so here maybe this particular console we can use for producer purpose. Similarly, one more console I need for starting the console consumer, just to see whether messages are properly going to that topic or not. Obviously we need to see the Snowflake table also, but for console consumer I will duplicate this session and then here I will log in as EC2 user. Okay, and from this particular one I will enter in that private EC2 also using this SSH. Now we have entered. Here also you will see that it is configured as 10 seconds, so that way timeout will not occur. Perfect. Now here what we will do, we will produce some messages in it. So bootstrap server we need to provide, right? So here bootstrap server is basically this one. I will copy that one and then here I will paste that. Same topic name we have given what we have configured in our connector as well, and for consuming messages we will run this console consumer. Okay, and then we will see that connectors are moving the data in Snowflake or not. So for that we will just query this particular table, right? So as of now fake data real-time demo we have not created, but in the Snowflake connector we have configured that whatever messages will be published in this topic, that should be pushed to this particular table, right? So based on that we can hope that this particular table should be getting data as soon as our connector will publish them. Okay, so here we have pasted that select query as well. So now just we need to wait for this connector setup. Let's wait for a couple of seconds. Once it is ready, we will publish some data from console producer. We will see whether they are coming in console consumer or not, and parallelly we will see that the data should be going to Snowflake also. Okay, right? So let's wait for the connector to be in ready state. Our connector is now in running state. Okay, right? Even you can verify in CloudWatch logs, it should be showing some logs. Let me just go to this particular log group. Okay, I'll go to that log group, or maybe I can close this one directly from here to here. I can go. So here if you see, some logs got generated, which will be basically showing that this connector is now running all the configurations whatever we have done, that it basically read from the configuration file and all, and it started running that connector. Okay, so now here I hope you can understand that this particular connector is managed by AWS only, right? Now let's publish some messages and we will see whether it is flowing to our Snowflake or not. Okay, so here I will start my producer here, right? And here in another console I will start my consumer. Okay, sorry, here first I need to go to the directory. That command we have to execute in the new EC2 and then we can go to that consumer, right? So first CD and then here our consumer started. Okay, cool. So here our consumer is there and I will keep my producer here. Okay, so here what I can do, first message I can publish some JSON data, for example hello and then world. Okay, we have published. So if you see in the console consumer it is coming fine, but it should be going to Snowflake also. But obviously it will not be immediately going based on this particular configuration, that is buffer flush time, buffer count, buffer size. It will be flushing the data after certain instance of time. So let's publish some dummy messages till then. Okay, so here I am having some sample events. For example, this particular one, let's publish. So this is having multiple key value pairs in the JSON data. Okay, another, let me publish, and here another one, let me publish. Okay, so that is done. In the console consumer you will see that all 4 messages are coming, hello world, then this email, this email, this email. Okay, so here we have published basically total 4 messages, right? 1 2 3 4, right? We will see that whether in Snowflake those 4 messages are going or not, right? So here let's do a select star and here it is showing that no active warehouse. So I will just choose the compute WH which is available by default in our free tier, and here let's execute. Here you will see that 2 messages came. Okay, here you will see that offset ID, partition number. So this first message hello world published in partition 0, and because this is the first message it is having offset 0. Now this message what we published, that was going to partition 1. In partition 1 it was the first message, so again it is offset 0. But the next messages should be having higher offset because in both partition data got reached. Okay, for example we can publish some more message 1 2 then 4 5 7 8 9 3. Okay, this is a YouTube tutorial. Okay, Kafka using Python. So some random messages I am publishing. So let's see. So here you will see that first initially what 4 messages we published, that all appeared here, and as you can clearly see, because our topic is having 2 partitions, right? So here if you see that when we created the topic, that time here we configured that partition 2, so that's why here partition 0 and partition 1 we are having. Then here one message got offset 0, another message got offset 1 in partition 0. Similarly in partition 1, one message got offset 0, another message got offset 1, like that. So even what messages just now we published, those will be also flowing. So let me publish some more messages. Hello, this is a Python demo. Then maybe here I can pass some JSON data. Hi there. Some random data I am publishing actually. But I hope you are getting the point that in this case the connector is running by AWS. We are not running the connector locally or in some EC2 instance, right? So here see 12, 78, 45, 93. These values we published now. 12, 45, 78, 93. So all these are coming. So let's wait for a couple of seconds and we will see all the messages will be available here. So here in CloudWatch, you will see that the flushing is happening. Those things also will be visible. Basically, internally Snowpipe is getting created, and using Snowpipe, the messages are getting written in the table in real time, right? So basically, this particular architecture is working. What we did, we launched 2 different EC2 instances, one in public subnet, one in private subnet. In private subnet, we are using the EC2 to publish messages in our Kafka cluster, which is running in private subnet, right? And here we have created our MSK Connect for creating the MSK Connect, first we need to create the custom plugin, which will be having the jar file where actual logic is implemented, right? And all the configurations we have configured while launching the connector, and that connector is consuming the data from the Kafka topic in real time and publishing in Snowflake. Okay, and this is completely managed by AWS only. It is not what we are managing. So that way the infrastructure part is handled by AWS. Now we can focus on building the logic and pipeline and other stuffs instead of managing infrastructure, right? That's the beauty of MSK Connect. So here if I just run it again, we published hi there messages came, right? So here eventually the messages are coming. So here whenever we are publishing the messages in producer, in the console consumer also they are coming. Obviously they will be coming in Snowflake also in real time. And here you can see the status that here our connector is running. So here if you see that these kind of records where we have passed string, that data is not coming here. Apart from that, all data are coming. Even if you go to CloudWatch logs and check, here you will see some places error. Okay, so that error is basically indicating that because here in the value converter we have configured that it should be using JSON kind of serializer. Here you will see that Snowflake Sink Connector demo for this error is coming. Like for example, test 1 to 3. For this one, it is not working. It is not able to convert. Failed to parse JSON record, right? So this kind of string data it will not able to parse. But apart from that, all kind of data it is publishing, right? So that is another point. So you should be publishing either integer or JSON data you can pass with as many key value pairs as you want, but not this kind of string data. This string data will be consumed here in the console consumer, but here in the configuration here we have configured that Snowflake JSON converter, right? So raw string obviously it will not publish. Okay, so here maybe I can pass 1, 2 and then here it will be taking 3, 4. Okay, suppose for example I am publishing this way, then here maybe I am passing 5, 6 and then here the value part I am keeping 7, 8, some random value. So here you will see that these kind of records will be coming, right? So that is just a key converter, value converter type what we configured. Based on that it is working. If Snowflake JSON converter is not working for you, you can obviously try other conversion mechanism, right? But here I hope you got the point that Snowflake connector is working in real time and it is publishing the data. So like here we have published 2 set 1, 2, 3, 4, 5, 6, 7, 8. We will see that those will be also consumed here soon. So let's see. So here if I just execute again, here you will see 1, 2, 3, 4, 5, 6, 7, 8. Those JSONs also appeared, right? So overall this particular architecture is perfectly working as we discussed. This is all for this video. All these steps will be provided in the description box or in the comment section. Make sure you are terminating the cluster once the POC is done, releasing the elastic IP what you attached with your NAT gateway to avoid unnecessary cost for your AWS account. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.